This conference will now be recorded.
Good morning. Thanks for joining us today. My name is Zhen Yu from Facebook Infra team. Anil is presenting with me today from Intel. We'd like to take this opportunity to share with you a new collaborating effort we are proposing to the OCP Hardware Management Group, the Hardware Fault Management Subproject. This subproject is a joint effort initiated between Facebook, Intel, and Microsoft. We prepared two presentations around this topic today. First part is an overview of the subproject, our motivation, our goals, and what's the plan in our mind. The second part will be a hardware fault handling case study presented by Microsoft. For the overview, I'm going to first share some common pain points of hardware fault handlings in large-scale data center. And then, based on those pain points, I'd like to share what our thoughts are on what the general goals of hardware fault management should be. Anil will then take over and elaborate on the details of this subproject. What will be our method? What are we trying to build with the community? And what are the milestones along the road? And how community can join us and collaborate together. So let's get right into it. How to deal with hardware fault is of great importance in today's large-scale data center hardware management effort. Today's typical large-scale data center consists of a large number of different types of hardwares from different use cases. It is easily a mix of hardwares from different generations, configurations, vendors, manufacturers, and so on. Together, these various hardwares define the data center servicing capacity. It is important to note that the capacity here is not just directly how many systems are available and capable of providing the services to the application traffic, but also how well these systems can provide the services. Hardware fault caused data loss and rebuild, application crash and unavailabilities, system cycle loss due to hardware retrying efforts are all contributing to this undesired system performance degradation. This kind of system performance degradation due to hardware faults are normally impactful and extremely difficult to diagnose and mitigate in the fleet. We shared a good example on how the firmware-based hardware fault handling mechanism could cause system-wide cycle loss that makes system performance suffer earlier last year. Besides the system performance, another headache large-scale data center has when managing the huge amount of different hardwares is the no trouble found in return material analysis process when dealing with the faulty hardware identified. Failure reproducing in a non-production environment is already difficult enough in the root cause process. Unable to precisely locate the faulty hardware components and provide insight for component failure syndrome makes the investigation even harder. A good and common example is when a memory fault happened and detected in the system. How do we know if it is the memory DIMM who is the agent at fault, or the memory controller within the CPU is the party that should be blamed? Last but not least, the complexity of managing various solutions of hardware fault handling from different vendors for different hardwares is also a big headache to the hardware management effort within the large-scale data center. This complexity makes the effort's scalability very much challenged. And if it cannot scale, it cannot work efficiently and effectively within a large-scale data center. These pain points are not unique, but we believe common within today's large-scale data center hardware management effort when dealing with hardware faults. We believe hardware fault management is a shared problem for those who manage large-scale data center, and it's probably about time for us to work together and find a shared solution. To address this problem together, we will need to first have a thorough understanding of what hardware fault management looks like from a system stack point of view. For a typical hardware fault handling solution within a system, it can be divided and categorized into these four different areas. The hardware themselves are responsible for detecting the hardware faults. Today's server hardwares are capable of providing hardware signals like interrupts upon encountering a hardware fault within various hardware components. In addition, corresponding hardware fault-related information, such as hardware register status and contents, can be prepared by the hardware for upper system layer agents to collect and analyze against those hardware faults. System firmware, once receiving the hardware fault signals from the hardware, can be configured to take the first response to the hardware fault, including collecting the hardware fault logs, performing first-level assessment on those logs, and taking pre-configured repair actions, such as switching to a redundant resource or direct a hardware component to contain the hardware fault to itself before it spans out to causing more damages. Operating system sitting on the layer right above the system firmware is primarily responsible for providing the kernel functions of presenting the hardware fault logs received from lower system layers to the management software and providing guidance to applications on how to react to those hardware faults. Management tooling software sitting at the highest layer within the system stack is the party implementing the system-wide hardware fault responding policy, such as tracking the hardware fault occurrences, profiling the hardware faults to provide hardware repair action guidance, as well as issue software mitigations if applicable. All four layers of the system stack need to work together, and considerations need to be taken at each individual layer when design and implement the actions upon hardware fault happens to provide an effective and efficient hardware fault handling solution. So what exactly are the considerations we need to take when providing a hardware fault handling solution to a large-scale data center? This is precisely the question the hardware fault management effort is trying to answer. At a high level, the hardware fault management effort is aiming towards finding a performant, actionable, and scalable hardware fault handling solution for a large-scale data center. Specifically, we'd like to minimize the performance impact caused by a hardware fault. We'd like to maximize the precision and the quickness of identifying the hardware fault. We'd also like to ensure the scalability of hardware fault handling solution. That being said, we'd like to propose this hardware fault management sub-project to the OCP hardware management group so we can work together with the community on this hardware fault management front for the large-scale data center.
Thank you, Zhengyu. Hi, my name is Anil Agrawal, and I work for Intel Corporation. So as Zhengyu explained some of the challenges in developing hardware fault management solutions for large-scale data center, let's do a quick recap. So the first one is how to prevent performance degradation and maintain the target uptime. And then speeding up the FRU isolation. FRU is a field replaceable unit. And then the third one is scalability of the solution across heterogeneous fleet. So in order to develop a hardware fault management solution and meeting these challenges, what we need is develop reference solutions and validation recipes. So let's look at what are the key attributes here and what we are proposing as a part of this hardware fault management sub-project. So first is we want to focus on baseline requirements, use cases, and tool sets. So what that means really is, so there are different type of large-scale compute deployment, like software as a service, platform as a service, infrastructure as a service. It's also called like a bare metal. And then there are all kind of different combinations along these lines. So what we have observed is from a hardware fault management point of view, there are some baseline requirements which are common across these different use cases. And then there are, of course, unique requirements. So we want to focus on the baseline requirements first, and then add the unique requirements for various use cases. And we want to pick like a handful of these profiles, and we're calling them as a profiles, and then key requirements, hardware fault management requirements in these profiles. So once we have that, now we want to define the solution. And so in order to define the solution, basically, if you look at any server, you will have processor, memory, IO devices, and then this whole firmware, OS, and driver stack. Now, once we put together all these pieces, there are so many different combinations of the end-to-end flow and configuration. So we want to then define the solutions or the end-to-end flow based on these unique use cases so that we have a more confined solution space. And once we have this reference solution defined, we can call it the blueprint. Then we want to verify and validate using these hardware fault management validation recipes. So injecting errors, different kind of ways of injecting error, and then verifying that the hardware fault management flow is working as expected, as we have written down in the requirements, and meeting the requirements. And third item here is, so how do we verify that these requirements are really going to help in developing the right solution? We want to define these case studies and reference solutions, working with the ecosystem, and then even let industry develop their own case studies based on their experiences and some of the key learnings. Maybe we want to fine tune then our hardware fault management solution, reference solution requirements. So what we are achieving here is we are assisting the management of system and hardware fault management in a large-scale data center and used within this OCP community. So we came up with this proposed roadmap for the sub-project. Kickoff, we of course were planning in March, and we are now in May. So through virtual event, we are doing a kickoff. And some of this timeline, of course, will now shift forward. But the basic idea still is consistent, that we want to develop a hardware fault management reference solution, and we will call that a revision 0.5. And then we will develop the hardware fault management version recipes, again, Rev 0.5. And in parallel, we'll be focusing on these case studies. So there is the first case study, hardware fault diagnostics, will be delivered by Microsoft in this virtual summit, in fact, right after this presentation. And then there are two more case studies that are in the pipeline, DRAM testing and telemetry, and then PCIe managed power cycling concept. And the objective behind these case studies is to develop white papers and share results within the sub-project working group, and then feed the learnings into the solution guide and validation recipe documents. So the call to action here is we are encouraging all the participants, our audiences, to join us to participate in the sub-project working group. We will be announcing a monthly meeting through the OCP portal. So look for that. And there are additional information will be interesting to also take a look at it. One is the hard system and hardware management project charter, which is posted on the OCP portal. And there is, we already have added the goals and objectives of this sub-project there. And then there are two presentations that were made last year. One OCP Global Summit, Facebook did the presentation. And then OCP Regional Summit in September last year, Facebook and Intel both jointly presented this platform hardware handling requirements for large-scale data center. This is where we introduced the EDEC driver enhancements to collect additional memory corrected error information, which can be used to precisely identify the errors within the DRAM and even within the DRAM, which of the bits are getting corrected. So with that, thank you very much for attending, and we will look forward to meeting you in person to eventually, and then over the virtual meetings in next few meetings. Thank you.
Hello, can anybody hear me?
Thank you. I can hear you. Can you hear me?
Yes, I can hear you.
I do not